Hello, and you are fine. My name is Joel Muthui, a teacher of mathematics. Welcome to my YouTube channel. Today we are learning about indices, which is in Form 2 work, and in junior secondary is grade 9 work. So now today we are looking to solve for the indices. But before you go to the question, make sure you subscribe, like, and comment on my YouTube channel. So, as I said earlier, this is from two indices. We are trying to solve for the value of x. As we look in our question, we have 9 raised to 2 power 2x minus 1 multiplied by 3 raised to power 3x minus 1 is equals to 27 raised to x plus 3. As you look at this question, it is implying the law of indices, which is called the multiplication law, which is between the two values of 9 raised to 2x minus 1 multiplied by 3x multiplied by 3 raised to 3x minus 1. And because it is an equal sign, now it becomes an equation. Now, if you look at this, you'll realize that the first part of the equation has 9 and 3, and the second part, which has the equal sign, has 27. So, in this case, we try to make them to have similar bases, because now, if we apply the law of indices, and the bases are the same, we can drop them and equate the powers. If you look at 9, 3, and 27, they are all multiples of 3. So by prime factorization, we can reduce 9 to a multiple of 3 through power form, and 27 to be a multiple of 3 through power form. Therefore, we have 9, which is just the same as 3 times 3, and because 3 appears twice, now that twice becomes the power, so it becomes 3 power 2, or you can say 3 squared. So 9 is the same as 3 squared. Then we have 27 through prime factorization. We have 3 times 3 times 3, which is the same as 3 power 3. The power is always the same as the number of times the number is multiplied by itself with. As you can see here, 3 has been multiplied by itself 3 times, so therefore it becomes 3 power 3. So in this case, where we have 9, we will substitute with 3 square, and where we have 3 power 3, we will substitute where we have 27, so that we will have similar bases of 3. So as we move to the second part of the question, so as you seen earlier, through the prime factorization, now in this case we have replaced this 9 with 3 square. So we will have 3 square, and now we open the bracket which was earlier of 2x minus 1. Then you multiply by 3 into 3x minus 1. And where we had 27, now we replace with 3 cubic, and we still take the power which was initially there, which is x plus 3. and you close the bracket. Now you can open the bracket, whereby this applies the law of indices of power of powers. So now, if you have power of powers, you just multiply the powers. So we add 2 into bracket 2x minus 3. So you open up, you will have 2 times 2x. Now you get 4x. And you have 2 times 1, you get minus 2. So this 3 now becomes 3 raised to 2, 4x minus 2. Then you multiply by 3 into 3x minus 1, which is equals to where we initially end 27. Now we have 3, and we open the bracket x plus 3. So we have 3 times x, get 3x. Then 3 times 3 is equals to 9. So we'll have 3 raised to 3x plus 9. At this particular point, now we can see we have basis of 3. So here, the first part we have 3, the second part we have 3, and the third part we have 3. Now we have achieved our goal of reducing the question into the similar basis. So this first part is 3 into 4x minus 2 multiplied by 3 into 3x minus 1, which is equal to 3 into 3x plus 9. Now, when the bases are the same, now we drop them and we equate the powers. So we are going to drop these 3's and equate now their powers. So here, the first power was 4x minus 2. Then we are going to say plus 3x minus 1. Why are we saying plus? And initially it was multiplication. Now, in the multiplication law, when we drop the bases, we simply add the powers. So that's where the plus is coming from. So now we have 4x minus 2 plus 3x minus 1 is equals to 3x plus 9. In this case now, we put the like terms together. Here we have 4x and here we have plus 3x. So we first of all add those ones, 4x plus 3x. Then here we have minus 2 and minus 1. So we have minus 2 minus 1 is equals to 3x plus 9. So we add these two to have 3x plus 4x to have 7x. Then minus 2 minus 1 gives you minus 3, which is equal to 3x plus 9. Now, because we have an equal sign, we still continue to put the like terms together, and the values of x now have to cross the equal sign. Wherever we have a positive, when it crosses the equal sign, it becomes negative, and where we have a negative, it will become a positive. So in this case, we want to put this 3x on the other side of the question. So we'll have here, it was positive. When it crosses the equal sign now, it becomes negative. So we'll have 7x minus 3x. Then this negative 3 has to cross the equal sign to the other side. And you can see clearly it was negative. So if to closest the equal sign, it becomes positive. So we'll have 9 plus 3. Now 7x minus 3x, you remain with 4x. And 9 plus 3, you'll have 12. Remember, initially we were to solve for the value of x. So here, we defined by the coefficient of x, which is 4. So you define by 4 both sides. So if you define by 4 here, you will get x. And if you define by 4 across the equal sign, now you have 3. So the value of x becomes 3. Thank you. I hope you've enjoyed my lesson. Continue following me. Continue recommending people for my channel for more updates and easy solutions for the mathematics. Don't forget to subscribe, comment, like, and share my work. Thank you.